Alright, this is a lecture I made about 2 years ago talking about P versus EXP and then one-way functions. Because a lot of times students will come and ask me questions, and if I'm getting the same one a lot, I kind of make something.
Or send a mass email.
Yeah. Let's talk about polynomial functions for a second. A polynomial function is made up of terms that are only added, subtracted, or multiplied. Okay? Since polynomials are sums of variables and exponents or expressions, polynomials are algebraic expressions that include real numbers and variables. Division, square roots cannot be involved with the variables. Variables can only include addition, subtraction, and multiplication. So if you see a question or a problem that has some sort of division, it's not that. Okay? These are all polynomial functions. Addition, subtraction, multiplication is all they have in them. Okay? So there's no division there. Okay? EXP, on the other hand, have exponents. Exponential because they are non-integer powers, because the second one includes division, or any problem that can't be solved in polynomial time, such as the knapsack. So it would take forever to try every combination of a simple knapsack if they're 2 to the 200th apart. So how big is 2 to the 200th? Someone asked me that actually this semester already. Knapsack, remember we use a simple knapsack that is only 3 or 4 long. Imagine the numbers being that far apart. So even if the first one was 1, the second one is bigger than that. So it's a very, very large number. Okay? One-way functions, especially in forensics, I stress hashes. Okay? So do you think you could ever take the picture on the left and reassemble it, become the windshield on the right?
I guess melting it down is not an option.
It still wouldn't be the same windshield.
Well, that's true.
Wouldn't be the exact same windshield. Okay. Now, could we go from the windshield on the right to the left? Yes.
Pretty easy.
But we cannot go backwards. We can't. It's like our passwords in Windows. I logged in here a few minutes ago. What did it do? Did it actually compare my password with my stored password? What do you think? A lot of people think it does. In the past it used to. Years ago it did.
That seems very easy to find.
Right. What it does now is, I logged in just now. It hashed my password, sent the hash across the network, and compared the stored hash. So we're comparing 2 hashes to each other. Okay? My password never went across the network, which is a good thing, because it's very easy to capture traffic, and we do a lot of projects with that. Okay? MD5. So there is an example of an MD5. MD5s are made up of hexadecimal values. So they include numbers from 0 to 9, letters from A to F. That's it, because that's hexadecimal.
And it's really annoying whenever they have that trailing 0.
Yes. Cause a problem. Okay. So that specific hash was produced by that sentence. This is a super secret message. Now, this hash, you agree they're different. I mean, totally different. Was produced by this message. I changed one character. I took the lowercase h, made it uppercase. So I changed one character, and look what it did to that hash. Everybody see the difference? That's what we want. We want that whole, remember that whole confusion diffusion thing? We want it so we change one little piece, it totally affects everything. If changing one h had changed one value in the hash, it's not good. It's a bad thing. Okay? So that's MD5. It has been broken. It's produced what's called collisions. Collisions are, say these 2 messages, 2 different messages could be found to produce the same hash. That would be called a collision. Well, the collision they found is a specific message. If you change a certain bit at a certain point, 2 different ones would produce the same. But it's like the odds of it are so slim. And next week we're actually going to cover DES. And in DES, it can be broken. But again, it's going to take a very long time to do it. Okay? Again, another short lecture. Just some people didn't know what an MD5 hash was.